Okay, so we'll create a new folder, but I'll pick up some elements. I'll need this one. I didn't divide it yet. I did these two lines. I will divide it, however, as in the proposal they don't cover the intersections. So we'll only cover the actual bridge between the two start points. So now I'm going to hit Ctrl C to copy it in the clipboard. And we'll do like this. This was the old model. We'll create inside the same project, we'll create a new structural level. Let's say it can be structure, call it proposal 1. And we'll insert some drawings here. Let's say from 31 to 35. The first will be the red line. Okay, and here I'll hit Ctrl Alt V or paste to original position. And now in order to be able to cut this composite element, I'll need to explode it first. And now I can remove the extra lines. This is a polyline. We'll say auto delete segment. This is the yes. This is the part we don't want. And this one as well. Okay. Now we are going to remove the extra lines. I think there's something left around here. Okay, so this will be the line, the red line. Now we'll make it again composite element. But here, okay, we have terrain, it's okay. Composite element. Okay, now we have it as a composite element. We'll export. Well, we won't export yet. This is the red line we're going to use. And now we will say here, okay, here it will be profile. Red line profile. So the first one is the red line drawn in plane. However, you'll see that we have some variation on the vertical section, and this one will be PDF import. And we'll leave this to background so we can see. And now we're going to import the PDF. Yeah, I forgot which page it was, 86 or something. 97, perfect. So now I'm going to import the PDF. I'm not sure of the scaling yet, so I'll do it in 2 steps. First I import it, and then I'll import it with a scale. We'll only import for the beginning page. You said 97 or? Okay. It's a protected PDF. We need to I've shown you before, but I don't know where is that version. We need that version where it was unblocked, let's say, unlocked. You have, yes, maybe you can find it. It would be helpful. The most time-consuming aspect will be to arrange the drawing to be at the correct dimensions. That's all. That would be time-consuming. So we will import now the file. File, import PDF data. '97. Oh no, this one was shorter, but it also contains what we need. Let's look again through it. So this is a shorter version. Okay, it's page 79. Okay, the thing we are going to do is like this. Where is also the red line? Okay, it's very far from the origin. Just a second. I'll hit undo. So let's measure some coordinates here. We're really far. This can be a problem, but let's write them down. So this is the x value, and the y value is this one. Okay, and now let's do the import again. Okay, it will import in the origin. No, 79 just. Now we'll move it to those coordinates, so it will be really close to the actual red line. So we'll go here to global coordinates points, and I'll place these two values for x and Y. And hit enter. And now we see both. We see the red line, which is on gray color as its passive drawing, and PDF. And now we'll check some dimensions, as this is not proper. We will need to do some scaling. However, we can do the scaling after we do the drawing, and we can use any approximation, as we're doing in 3D, we're not doing the final draft. So let's see, just to measure dimension, to see how far we are from the truth. Let's say this one. So it's somewhere around, okay, it's strange. We'll calculate this, but first we'll draw the two sections. We've done this before, but I don't know if we have them, and last time one of them had a problem, so I'd prefer we draw them again with this function with polyline. So we'll make sure it's a closed surface. So I'm going to first try to draw this over, and then we'll scale some dimensions to be close to the real cross sections. But it's better to do the dimensions on the vectorized element than on this pixelated, as as this type of elements, the BMP, are pixel based, so we can't snap to pixels. But it won't take us that much time, and as the bridge is big, it won't affect this approximation. The general aspects or even the quantities won't differ that much. Okay, here will be the symmetry line. Okay, this is the first one, and now the second one. Okay, we'll also do some copying of it. No, not yet. Let's also do the inner part. And one essential aspect will be to do a conversion from this first cross section into the second one. So the second one we won't draw, but rather we will change the first one, because for doing like this we will be able to maintain the number of points, because the bridge modeler can do the transitions between two cross sections as long as we have the same number of points. So we will make sure that the numbering is the same by doing this, only just doing some modifications, and we won't have any surprises. So this is why I'm giving more focus to drawing the first part, the first cross section, as the other will be just a modification of the first one. So after I draw the first half, I'll do a symmetry line. I will try to bring it to these coordinates, or show you how to do this, and then we'll do a copy of it and export it and modify it to obtain the second one. Okay, now we're going to move this one. Okay, we don't have the shortcuts. I'll place them as it's annoying to work without. Customize. Let's do some fast shortcuts. Are you holding shift button? Okay, no. It was acting as if you were holding shift, but things went good again. Okay, now we also have the old shortcuts. So we'll remove the extra segment. Okay, now we'll do some scaling, or now in order to show you more, I'll just leave it like this. And because okay, I'll show you again just to, but I know I've shown you before and you did a good job in scaling. So the main idea is like this: we start adding dimension points and the same unit, so it's easy, millimeters. Okay, and for instance we'll need also this vertex. Now where is the middle of it? This one. So for instance, if you want to make it 10 meters wide, we have now 4.140, so we'll do like this. Let's activate the calculator. So it's 10,000 centimeters minus 4140 divided by 2. So we get 2930, and we'll change like this: modify point. So I do a window of selection to select the points I need to modify. Did you remember the value? Okay, neither did I. It was 290. 29 here. But I need the extension to be horizontal. Okay. There's also a problem with the height, that's why okay, no, it's not okay. 2930. Oh, we're in meters, that way. That was the problem. No, you see, it's good. Oh, okay. Okay, now we'll try with the tools part. With the height. I think it's also somewhere around double. It measures this line. So we'll also do the scaling here. Let's see the difference between them. I copied the value so I don't have to remember it. And then modify points and do okay, and then there will be some extra adjustments for the thickness, but I'll leave it for the moment like this. So this will be the first cross section we'll be using. And for the second cross section, we'll do some modifications. Okay, I'll copy it also with these annotations. So we get here a reduction from 10 meters to this 5 to 80 something. So we say 2.5 and 2.5 to simplify the process. And then we'll make it also taller. But what is essential is the fact that we are changing the first cross section to look like the second one and not creating the second one. If we try to create the second one, there's the risk that we may enter more points than from the first one, and then the bridge modeler wouldn't work as it identifies it can't follow the points because he does the interpolation between the points we give him. Okay, and also let's modify the height. It was somewhere around it was 3.7 and now it's 9.7, so it's 6 extra meters.
Da. Vezi în noțiunea aia de bază, sau să ne gândim ce dăm la fiecare, să-și bagem în cursul, știi? Primele părți alea comune. Da? Sau de unde le separăm, am avem un curs de bază,
So we have these two cross sections. Now we'll send them to the library. Okay, we played with those cross sections. Let's see. Proposed. One. But we don't want dimensions, so we will use filters. I'll say new symbol 1, and I'll assign this filter to be line and polyline, so we won't pick up the dimensions. Okay, and it's not relevant by which point we pick up. We'll apply the filter again for the second cross section. Okay, and now there's a second problem we need to solve, which is this vertical profile. We see that we have variation on the vertical side, and we'll need to draw, let's say, the red line as a longitudinal profile. So we'll use line or polyline, it doesn't really matter. And we need to pick up this upper part, or we can choose, okay, we'll choose this upper part, and then we'll choose that the reference point for the cross section will be the center. And we start here, and we can actually go through these elevation points. Okay. And now we have this vertical longitudinal profile, and we'll need to make it as long as this one. So I'll measure the length in plane for this one, and then I'll scale this so we get the same length. So we'll do like this. I'll measure. Actually, I'm going to measure with we need the length of it, so we won't measure like this, we'll just measure with this one, length, and hit this point. Oh, doesn't identify. Okay, we need some extra operations for this. The problem is our bridge is not straight in plane, so the length of it is pretty long, and the profile should be the same length as let's say the length of this curve. In order to determine the length of this curve, I'll need it to convert it into a single polyline. So I'm going to do this. I'm going to explode the element, explode composite element, this one. Why it won't explode? I don't know why it doesn't want to explode, but I'll convert it to a 2D line because I need the length of it. So, or maybe if I choose it here, let's say if I can see it in the properties window, maybe in the attributes. Have here the length, okay. So we didn't need that many operations. It's 3257 meters. I'd like to copy this value. Okay. So we don't need that many operations. We only needed to know how long the bridge is. And now I'm going back to this one and I'll do the scaling because we in reality we need a 3D line which varies in plane and varies vertically. This profile that is drawn here. This is a section through the bridge. The problem is the bridge is not straight. The bridge has some curves in plane, and this is the unfolding of the bridge that we see here. So the unfolding is longer than a projection in the plane. So we need to know the exact length of the bridge, and to make this longitudinal profile according to that real length. So this is why I measured that distance. This is how the bridge will vary in height, and the only thing I'll be doing now is do a scaling on x coordinates. Also going to place here a dimension line. And this time I'd like it to be in meters, as I copy the value in meters. Okay, and now I'm going for this function called resize. I'm going to select this, pick up the origin, which is the start of this elevation. And now we're going to give some factors for x, y, and z. There's only going to be a factor for x, as on y we want those dimensions. Hopefully they're correct. We will actually we'll maintain, I think. No, let's look a bit. We need to know the scaling, because usually in this kind of profile it's not, the y factor is different than the x factor, so the bridge can vary in height for a meter or two, but in length it can go 100 meters, so it's not scaled. It's not the real representation here, so we won't mess with the vertical variation. So we'll only enter the delta x. So we have here, we had here that value. Where is it? Okay, we don't have it anymore. I shouldn't have typed it there. Okay, and now we're doing the scaling. So to calculate the delta x factor, we paste the value we need and we divide by the value we have. But let's work in meters. So meters, and we do the stretch. Or next we paste the value we need, then we divide by the value we have. On y we won't use the same scaling, we'll maintain it to 1, and on z 1 as well. It doesn't matter z, as this is 2D construction. So now we have them as the same length, hopefully. Let's see a dimension line. Yes, it's similar. Okay, I will delete this dimension line. Okay, so this is the profile, because this profile will need to export it into an LPR. So we need to export the coordinates for this file. We'll go to terrain. Okay. Okay, we need it as a longitudinal profile. We'll do like this. There are still some operations here. We'll convert it into a 3D line. We'll rotate it upwards. The problem is the bridge is almost straight, so I think we'll give it 2 factor for the vertical side, as it's almost straight at this scaling, and I can't believe it's in that drawing it's exaggerated, but still we'll need at least 2 meters difference. So I'm going to do resize again. 1 will be on delta x, and let's say 5 on delta y. And now we have some variation. We can almost see it. But we have some variation on vertical, because in that that representation is really scaled. So I told you the differences are very huge between the variation of the height in report with the variation in plane. So now, in order to create that LPR file, I'll convert this into a 3D line. I'll rotate it in plane. In 3D actually, as I want this to be a vertical variation. 90. Okay, now this is a 3D line we're going to use to generate a digital terrain model and then export the point. The only thing is we needed, just before doing this, we also need a 2D line, which will be this line. So I just add one 2D line, as this is how the longitudinal profile works. It needs a line along which it generates the profile. Okay, what I'm doing now with this terrain, you can use for all bridge proposals. So what I'm doing now, you won't need to repeat, as you'll have the files with the points and you just can use them. You will work more on the cross sections to obtain all the other proposals. So don't worry that I'm using so many steps, as you will benefit from the files and you won't need them to, unless you want to practice, you won't need to do them again. Yes. We could have kept the first line, but I forgot. So I created another line. We need a 2D line, or what? This line is only in plane. This is for the plane. So the red line is a 3D line. However, the software with this module, the bridge and tunnel function, it needs two lines. One is the variation in plane, which is this one you drew, and the other is a variation in elevation, which is the second line. Combining the two lines together, by combining the two profiles, we obtain a 3D line and the bridge. Okay, so
Nu s-a aprobat de prelungirea proiectului până cu încă 3 luni. Din cauza că n-am putut să facem achiziția la vreme. Și rămâne pe vechiul orar. Până la alte chestii. Deci dacă nu apare niciun fel de aprobare, pe 15 februarie este pe 15 februarie trebuie să avem și urmează să cerem testele. Nu, să cerem să facem testele. Toți, și documentații. Și eu am fost convins că se va prelungește până în mai.
A venit decizie?
Nu a venit nicio decizie, tocmai. Nu a venit niciun răspuns. Trebuia să vină până în 30 de zile.
Okay.
Păi și când s-au făcut 30 de azi?
So you need to, the other way, you need to convert this 3D into a digital terrain model.
Când dormim, trăim aici.
I don't know if it will work.
Da, și asta e asta. Mă duce distanță. Să nu deranjăm activitatea. Mă rog, o să fie hotline, o să fie mai subțire, dar... Nu știu, o să...
Okay, we'll do another strategy. I don't know what's this error, and I don't have the colleague is not in the office who knows better this. So convert 3D entities. We can do the variation in the modeler, so we won't do like this. We will do a 2-meter variation at where we place the piles. So we will import just the 2D line and we'll create the profiles accordingly. So because I don't know what's that error with the line. If we had a 3D line, it would be really easy to generate the ALPR, but we don't have that line. So what? No, but we'll do this variation. So we'll start with here we see 50 meters. It starts around 50 meters, no, 53 meters, and it goes to the top to, well, to 60. So it's a 10 meters variation. So we'll pick on the middle a 10-meter variation, then that's all. So we can use only the line we drew to generate this one. I don't remember. Okay, we'll do now the rest of the part. So we'll do like this. We have this line. We export the points. So the red line, and if you had success with that ALPR, but it's hard to simulate a 3D line as we did. Our points were collinear, so it had no purpose in doing that line. But we can import only this plain line, and we'll do a variation of the height of the points. I will hit OK now. Just a second, I think it's I didn't export correctly. I needed the composite element. So terrain, composite element. This is a composite element we're exporting. This is not a composite. Oh, yes, it is composite. Composite element. I'll select RE2 as format for the points, and this is the element we're exporting. Okay, now we'll go back to Bridge Modeler. We import the root. Okay, that matter. Okay, so this is these are the points it registers. So these are actually the points where we can do modifications, we can change cross sections. So what we'll do now is assign the first cross section, define cross section, and we will use this one, get cross section from symbol catalog, and we'll go to project, and these are the cross section. Just a second. They don't like our cross sections, but I'm not sure why. This would do. Doesn't work, I think, because they're not polylines, but we'll just convert them into polylines. Let's see why the others worked. Just do a small fast comparison. So this is a polyline, and still polyline. So it's done in this similar way. While this one so it's a polyline. Oh, the small line. I think this is the problem. So I need to save it over this one. Let's test it now. They still don't like the cross section. We'll use the first and then we'll do a modification of the second. I don't know exactly the problem, and I don't have the patience to draw it again. Well, what I'm going to do is save this. And drag the first one, as the first one worked well because it was done by you and you are more careful. Okay, and we'll just create another, say, a cross section 2. With those type of modifications. So I'll move it in vertical side and then change the okay.
Nu, la pus, dar nu ca să vedem ce la știu acolo, acolo. Acolo a pus, că l-a pus și ala.
Dar ce sunt alea? Că nu găsesc.
La CNFPA.
CNFPA?
Exact, a zis să vedem să mă ajung cu acolo.
Am făcut administrativ și acum am pus temperatură deocamdată și o să mă pune. Ai zis că a făcut un film?
So this is the first cross section. This is the numbering points, and now what we'll set is by which point it should be snapped to the red line. So it will use point 1, and to make sure, I'll go here, right click, and say define reference point, and it will be point 1. So this way we know that the red line is centered to the top of the cross section, and then we should move through this this isometric view, and we should go now to some point. Let's look to the proposal. So we have them like this, let's say less than a third will have constant cross section. Okay, we'll divide it by 5. So we have constant up until this area, then we'll do a small variation on this area. We bring back the first cross section and then some variation as well. And we'll do this by, how do I close this? Can you close this PDF? I don't find the X. Okay. We'll go like this. So we should also watch this axis. It's pretty blocked by the points. So let's say in this point, normally we should measure, to do some calculation to know exactly where the variation should be, but you can divide it as you want from the beginning. When I imported the route, it asked me what is the distance I want these points from, and by default it was 25 meters. I could have chosen any other division. So what I'll do is for points up until point 37 we have cross section 1, and then on point, let's say in this area, so in area 60 we'll have the second cross section. So we'll go to 60, say yes. Well, you can only know if from the beginning you do these divisions by points. And normally when you receive from the ones who designed the road, you get this numbering of points. These are called pickets or key points, and these are given by the one who designs the road. So normally you know this numbering is corresponding to the road design. So they can only start with a number, a different number than ours, but it will be basically the same. So in a real situation, we would choose the distance by which we have the points from the road, and then we have this determination. So basically they determine in plane at which point they change the cross section. So now we're going to do it to look as in the picture. So in cross, I said in 60, I'll provide the second cross section, and then starting 38, it will do the variation. So it won't do the variation from the first point, but between 2 points I pick. So define new cross section for points 60, it will be cross section 4. We close this. And now the program tries to do the variation in between the first point and this one, but we don't want like this. We'll start from point 38. So at point 38 I'm going to assign a section which will be still section 1. So this, by doing this, I make sure that between point 1 and point 38 I have a constant section. So the bridge is somehow here in this small window. Okay, we'll see it when we build it. So what I did so far was like this. We can see how it varies. So starting point 1 we have cross section 1, and this doesn't change until we get to point 38. Starting point 38, the section starts to change, you see? It changes up until point 60, when it becomes constant. Now it's constant, and let's say if we used from 38 to 60, how many points, to do something symmetrical. So we'll get here, okay, calculator again, it's 60 minus 38, 22 points. So if I add to 60, I get 82. So I'll go to 82 now. And here I'll change the cross section back to cross section 1. Okay, and we'll keep this cross sections as in the PDF, which means we have an area of a few meters which is constant. So we'll leave that up to 90, and then starting 91 we'll need a variation. So we'll do the same 22 steps, so it will be 111. We'll go to 111. I'm going to place here cross section 2. And now back to 90. Okay, 90 is okay, it's cross section 1. But we want to make sure that 90 is actually cross section 1, because now it did a transition from the last point. So I'm going to do now define new cross section and select cross section 1. Because as I mentioned, I want to have a constant 10 points with section 1. So now if I go through this area 90, 89, I have the same cross section, and then it starts to vary. So this is variable, constant for 10 points, then it varies again up until 111. And now we'll go 22 extra points, so we'll go to 133. Yes, so the variation is done only between the 22 points. I picked it as an example. If we need something precise, we can think it in plane and then do the division. So this is now, yes? We can divide the original line into as many points as we like, and then we can see the number of the point. So we'll do this operation in plane. So we will establish in plane where the pile would be, so we know where we change the cross section, and we note down the points. So this is the only way. we do the strategy in plane, so in 2D, where we should do the variation between which points, because we can, in all plan, we can divide any 2D line in as many points as we like, or as the distance we need. So this is how we would do the things precisely. Okay, now it's converted to the one section and it's constant. Now let's see the result. I'm going to save this setup, as it will be really useful for you. This call, okay, proposal 1, but the only different thing you'll do is change cross sections, and you can use almost all the as far as variable cross section go, we can use them for the other proposal. The only different is the one with the big pile with the cables, but we'll do the cables as well, and there we have only one element. We'll do it with 3D modeling. Okay, now in order to export the bridge, we'll go File, Export Route, and it asks us for coordinates, and I'll choose this line, and then I can exit the settings. I'm not sure if it used the coordinates. Okay, it moved it a bit, don't know why, but we'll move it back. It's up here. Okay, so let's see in animation what we managed to do. So we have variable cross sections. Let's start from one end. So this is the starting cross section, and we can see that we'll have variations here, so between the points we established, and we can change anytime we like these variations. So we can rethink the strategy where we should change cross sections, because the program tells us where we did variation. So you see, we should do variation where we have the big vertical structural elements, the big piles. So here it's already, you see it's taller, so it's the second cross section. Then this is a portion where it should be constant. I said 2 points, it should be constant, and then we get the variation again, and section 1. Now we can also obtain, because you see the bridge varies in plane as well. It has these curves, you drew it actually. We can also overlap with the map. The map is here. Teo, poți să sunt pe Cuciuh de la VP Holding? Mă sună acum. Okay, and here is the ultimul apel. That's it. Let's check. I'll also send you a terrain. I also have the terrain, so you can see the animation, the Google map. But now it's on our proposed terrain. Let's see, the bridge because I told you the red line is the most important part. If we had it in 3D, we'd also have the variation. But this is where we drew, so we have it there. And I'll deactivate the map now. We can also obtain that profile automatically. The profile we see in the PDF. So we can go here. So the points are good. You will only need, if you want to do the other proposals, we'll see together, but mostly you'll just need to adjust the cross sections, and you can establish on your own. I'll show you how you can establish more precisely where to divide points and establish for which distances you need the crossing between the two cross section. What I'd like to show you now is this section along curve we can use. We'll go to this line. So element for clipping path will be this line, and we'll look from, let's say, from down to up, and this is the result. So this is actually will be the unfolding of the bridge. This is the cross section, and we don't have the vertical elements placed yet. If we were to activate them, well, actually I'm going to activate them now, because you already created them. So I'll activate the rafter, the piles. Okay, the only problem is the bridge is lower. Okay, it's not centered. I don't know why. Okay, we moved the bridge, I think. Okay, we'll move them as we like. We just need to have one element, and then we'll copy along the line at the distance we need. So basically, if we go with this section along curve, we don't have vertical elements now, but if we had and also had the terrain, we would see here more than just the line above. But basically this is the cross section, so we also see the variation. Here we see the fact that it has variable cross section, and it can be annotated. So this is actually the unfolding of the bridge, so it's not the view from front. If we look from the front, it will have different result. This is the view from the front, and what you see, this is how it looks as if we were looking this way to the bridge, because of the fact that it's variable and plane. While if we use the section along curve, it will do the unfolding, so we always will look vertical on this line. Okay, so let's look a bit on the other proposals.
Oare doar să mă modificați, sau dacă o modificați dumneavoastră anterior? Da.
Okay, so there will also be needed those. You have drawn already the pile with rafter and the big structural element, which you'll just need to place at these distances along the line. So you place also the vertical elements after you draw the deck. So with the bridge modeler, we only model the deck. We place these vertical elements underneath the bridge, and basically we have the bridge. The other proposals will be like this. They have one. This is not that interesting. It's a constant. It's not constant, but we don't have the variation of it. So it's still composite, but we don't see the variation. Here we have a change, which is pretty small. This can be done, the third example, as it only lengthens these two vertical elements, you see? Okay, but this one can be yes. Yes. We should also do this one because it's really nice and it's easy. We won't need the bridge modeler, so we'll do with cons.
Da, dar vedeți, dacă intrați în Eurocod, dacă intrați în Eurocod, în 0.006, o să vedeți că aveți pentru diametre mai mici de
Okay.
20 factor.
Yes.
Bine, e puțină. Da? Puțină
Yes.
programare aici.
Yes. I understand. Okay. So you should think of a strategy, and then when we meet, we'll talk what problems you face and what proposal you decide for us to do together. And we'll actually do the bridge according to these drawings. So after we create the deck, you see here you have all you have the measurements, so you can know for which distance you go. You divide. So let me show you how you can divide the element into points. So for instance, we have this. This can be, I'll place it here in delete me, just for example. And we'll have this polyline, which can be the bridge. And now we have a function called divide element, and we can choose this to divide this line, for instance this polyline, into a number of elements. So we can actually measure, let's see, if the polyline is, we'll go here to assign modified attributes, and you can see it's 13 meters almost long. Let's say we want every half meter 1 point, so we'll go to 26 points. Divide, we click on this line and we'll say we need 26 divisions. And now you see it divided this into a number of points. Yes, and now we can easily decide at which point we can, actually we could use picketing, so it can also place numbers. There's another function here in terrain, I think. Stationing points. So if we click here, we can say the difference between 2 points and say half a meter, 0.5, and we get the same result. So we actually mentioned this. Yes. You can divide in more lines, so you should divide into smaller portions, and you can import in the same function. You can import more routes, so you combine them afterwards. You combine them inside or separately. You can do different portion of the bridge, or you can import. You see here when we create the points. In the bridge civil, we can say, when you say import route, we can say as first route, and then we import again in the same folder after current route. So you can assemble these routes here and then just assign cross sections. So you can do just a straight line with the distance you need, and you divide it by 80, so you don't add any other points. Because here is how often you need to divide the line you import. Here is the distance. By default it says 25 meters. Okay, so I think you need to test around what I've shown. I'll give you the recording, and hopefully we meet tomorrow and discuss. I would like on the same time. I'll let you know if something appears. As far as I know, nothing appears. I'll be in the office, but if something should appear, I'll let you know on Skype. Well, I told you from my now it would be the same hour, so 8 a.m. for you. It would be okay for me, but I don't know exactly what things are planned for tomorrow. As far as I know now, it's nothing planned, but I don't know what can appear exactly. Yes, yes. Okay. Sia engineer. Well, I need access to the other computer to release your license. I will need TeamViewer to go TeamViewer on the other computer. So I'm going to close the